Well, good morning, everybody, and welcome to NASA's Johnson Space Center and our series of briefings today throughout the day on Discovery's final voyage. This one, of course, to the International Space Station, the 39th mission of Discovery. Our first briefing is a program overview. Joining us for this first briefing is John Shannon. He is the Space Shuttle Program Manager. And also joining us is Dan Hartman. He is the manager for ISS Operations and Integration. He also chairs the station's mission management team twice a week, so he stays fully abreast of everything that's going on with all of the international partners around the world. So we'll hear from both gentlemen, and then we'll throw it open for questions. And with that, I'll start with John.
Okay, thanks, Kyle. Well, it's good to see everybody again. It's been a while since I've been here to give you an update on the program status. We've been very busy since our last launch. Concerning the STS-133, we had a good program review about 2 weeks ago. We have had a very smooth flow on this vehicle and the stack since STS-131. The program, we really had no issues that we were going to carry forward to the agency flight readiness review on Monday, and more a status of just how things have been going in the program and the processing of this vehicle. We did have one problem that started last week with it's been pretty heavily reported with one of the fuel lines with monomethylhydrazine in it that we use for the thrusters and the orbital maneuvering system engines. And we had a small leak in the plumbing at a flange fitting. And the team has been working that very hard over the last week. You probably have heard that we did some troubleshooting on it. It looked like the leak stopped, but the team, the tenet that we have is that we fly with accepted risk. We don't fly with unknown risk, and I characterize this as an unknown risk case because we didn't understand why we had that small leak. And so the team is working very hard right now to set up all of the equipment to drain the tanks. They'll do in what they call educting, basically take it to dry the system, take it down and do a vacuum on it, get it all safe, and then we'll break that flange open and look at the metal sealing surfaces, look at the two sealing rings. They're like O-rings, they're metal covered with Teflon that are inside there. And we'll understand the situation, and I fully believe the team will get that back together this weekend, and we'll be in good shape to go fly. So that's really the only systems issue that we had for Discovery in preparing for this flight. Just a few things about it since this is a program status. It's pretty exciting that Discovery is going to take up the last major United States module to the station. Dan will talk about that some more, plus getting ELC-4 up. I think we're making good on our promise that we would get the space station in the absolute best possible config we could with spares and equipment before we retire the space shuttle. When we came out of the flight readiness review, we set the launch date as November 1st at 4:40 p.m. Eastern Daylight Time. The window for this flight stretches from November 1st through November 7th. The mission is 11 days, and then we have one extra day that we can add. We'll have the consumables we predict to add a 12th day. If we launch at the end of the window on November 7th, we would not have that additional day option. We would run into some issues. So if we launch between November 1st and November 6th, we would have the potential of adding a 12th day. If we launch on the 7th, we would only have 11 days, but the full mission could be completed in that time frame. The range is pretty clear for that time. There was a Delta launch in there. It's moved out to November 15th, which is after landing for us, so that helps us out quite a bit. There's a SpaceX Falcon 9 launch currently on the 8th. It is not an issue for us from the range because we use one of the solid rocket booster recovery ships to go get the Falcon 9 first stage. And what we understand SpaceX would do is slip day for day with us to allow us to have that SRB ship on station to recover their stage. So if we go on the 2nd, they go on the 9th, and so on. If for some reason we have some kind of an issue and we don't go between November 1st and 7th, the next window opens Right now it's December 1st through the 5th. It may end up being extended a couple more days, the 1st through the 7th, depending on what happens with 25 Soyuz, and Dan can talk about that some more. It's an interesting flight. Besides the activities we're going to be doing at the International Space Station, we'll again be doing our boundary layer transition DTO. This is the types of things that we think we should have been doing on the space shuttle throughout the program, treating it as a flight test vehicle. That's the small bump on the underside of the left wing that will trip the boundary layer and get some additional heating in one of our high tile thickness areas. We've got thermocouples under there to understand that. We'll image it from the ground and from infrared cameras that are flying. I was privileged to go to an AIAA conference about, they have very few concerts, about 5 months ago, and there were 11 papers on just the science that they've gotten back from the boundary layer tripping. So it's an environment that it's very difficult to collect data in. I think that data will be very useful to a variety of vehicles that will be designed in the future. You know, we have had a mantra throughout the program that, you know, we're not, even though the program is ending, we're not going to stop trying to improve the vehicles. And we're going to try and make the very last flight the very best flight. And we're going to, as we learn things each flight, we're going to include that into the processing and make it better and better. For this flight, we have a full ceramic plug redesign on a number of different areas where you take tiles off to get equipment underneath. You have tiles that you put a bolt through to attach it to the structure, and we have these ceramic plugs we put in those bolt holes. We lost a couple of them a few flights ago. Discovery is flying with a redesigned plug that it actually flew on the last flight as well, and it showed excellent performance, and we did not lose any ceramic plugs. We have some thicker, tougher tiles. They're called Brie tiles, and we added 33 new Brie tiles to the underside of Discovery on this flow, and there were 24 of them were on the forward edge of the ET door. So we put the tougher tiles along the brakes and the fuselage, where if you had some kind of tile damage, you could potentially have a significant damage to the structure of the vehicle. So we put those Brie tiles in there. It's a total of 213 on Discovery, and we're in very good shape to, in case we get any kind of foam or ice or anything else, that Brie tile adds a significant layer of protection to us. We also worked on the rudder speed brake tiles. We lost half of a tile during ascent 2 flights ago, and we did a lot of rework on shimming those tiles and making sure that they were in good shape. We repaired some cracks. So, you know, we have not just been kind of sitting back saying, "Oh, Discovery's going to fly one more time. We don't need to do any upgrades. We don't need to do any enhancements on it." That is not the attitude the team has taken. They are working just like they always have to try to make it the best vehicle they possibly can before we go commit to flight. I am sure I will be asked about workforce. We went through a significant downsizing right before October 1st of this year. We're basically half the size. The program overall is half the size it was 2.5 years ago. And from a prime contractor standpoint, the shuttle program currently has 6,439 prime contractors. We were at just over 14,000 in 07. From a civil servant standpoint, we have 1,139 civil servants that support the program, and we were at about 1,800. So it's a little more than 600 civil servants that have gone off the program in the last 2.5 years. We expect that we'll have one more reduction in the team members on the primary contractors. In January, it will be about 320 people. And then we'll hold where we are from a workforce standpoint, because we'll be down to really just operations team and critical sustaining engineering skills. At that point, if we end in after the February flight, then the final layoffs would be in March, would take us down to about 300 people total to do transition and retirement activities. If we fly in the summer, then roughly a month after that last flight, we would do the same thing, and we would reduce at that time. I would just, I would end by saying that I'm really proud of the teams that are working on these vehicles with the obvious distractions that we have with budget discussions and transition activities. It's a very proud group, and that really shows in the focus that they put into reconfiguring these vehicles and getting ready for flight, and just a tremendous amount of pride that they have in the successful missions that we've been flying over the last several years. And we're prepared to send Discovery out on a very high note. That's all. Dan.
All right, thank you, John. Well, we certainly look forward to the ULF 5 mission. As John mentioned, it'll be our final module that we bring up to the International Space Station, our permanent multi-purpose module. It's Leonardo FM1, commonly called the MPLM. We've upgraded it and have it ready for its long duration stay on station. And also ELC4, and I'll talk a little bit more on what we plan to do with that. That'll be the third of our 4 ELCs that we'll be delivering. We have one more coming up with AMS on ULF 6. The PMM will be delivering 6,500 pounds of cargo. We have another 1,500 pounds in the mid-deck, ranging from ORUs to consumables to actually 3,300 pounds of research on this mission, which is a very big gain for us. The research guys will be flying their last express rack number 8, and that rack in and of itself can handle and accommodate 10 payloads. We'll be moving the PMM to the Node 1 Nader port, and the port's been checked out and it's ready to go. So we feel like we're in good shape there. A little bit more work to do, but all indications is we're just fine. Some of the major spares we'll be flying up on this mission that'll be in the PMM is a spare distillation assembly. That is for our urine processor. We currently don't have a spare on board, and so we'll supply that. We have 3 more in the pipeline to come up as we need them. But that's one of our critical ORUs we'll be getting up. There's a spare CAT reactor, which is kind of the heart of our water processor assembly. It'll be coming up. A Seadra bed. We have a couple more beds to change out on our Seadra. We have 2 integrated racks of Seadra presently. One that operates in the U.S. lab, one that operates in Node 3. We'll be actually doing some work on the Seadra during this mission, and with the intent of bringing home one of the beds so we can retrofit that and get an upgrade on that. And we also have a spare treadmill coming up on this mission. So that's some of the major cargoes. Once we get the PMM on board, it'll be used primarily to help us with our overall stowage and logistics concerns that we've had. As you know, we've been just stuffing these flights completely full. We tend to overflow ourselves on the allowable stowage locations, so we've been making do. We're actually going to spend some dedicated time later this year to really try to go get our pantry set up, our stowage integration efforts in line to make it more efficient for the crews to get to certain pieces of hardware. As far as the ELC4, it'll be going to the S3 truss, lower inboard. Basically, it's only flying up with 1 ORU. It is one of our radiators, one of our prime radiators of our 6 that we have. It'll be our only spare up on board. And on the bottom side of the ELC, we have 5 what we call FRAM adapters. No ORUs are flying up on those specific locations. 2 of the ORUs that are coming up on HTV2, the FHRC, which is a part of our thermal control system as well, and a box that we call the cargo transfer container. And inside that, it contains 12 of our remote power control modules, our power distribution boxes that go outside. And so when we get to HTV2, we'll actually have Dexter be taking those off of the pallet that comes up with HTV2 and transferring those over to the ELC. Be 2 EVAs on this flight with the primary duties of preparing and getting the external pump off of the MSS. That's the pump that we had fail on the segment about 3-4 months ago. 3 EVAs to fix it. We ran out of time to relocate that thing back to ESP2, so we'll be doing that on EVA1. And then on EVA2, we'll actually vent the remaining ammonia out of that pump module. all kinds of water transfer, nitrogen transfer, oxygen transfer. The shuttle will be able to top off our airlock tanks. Again, we kind of ran those down about 75 pounds for the EVAs that we conducted for the pump module, so we'll be able to top those off. So we're looking forward to that. As far as the onboard systems on station, we're ready to go. We're ready to support our consumables are in very good condition to support this mission. As far as kind of recent activities on board the station, over the last week or so, we have been installing the Sabatier system into the OGA rack, or oxygen generation rack, and actually first time we tried to activate it was last night. We actually did generate water from our Sabatier system, so that is a major accomplishment. Went to processing mode probably around 8 o'clock last night. We subsequently had a shutdown that I think the teams have well understood, and they're probably in the control center now, bringing that system back up to speed. So the Sabatier is kind of the last leg of our regen system. It's taken the carbon dioxide from the Seadra scrubbers. It's taken some hydrogen from the OGA system, combines those, and we produce water, and then vent the gases overboard what we don't use. When up and fully operational, it'll generate about 2 liters per day for us. I mentioned Dexter. We did do a checkout of Dexter with an RPCM several months back. We got into a kind of a high friction force in pulling one of our RPCMs out. And so we stood down on Dexter activity during that time period. Although I would say during that time period, Dexter performed just fine. We just didn't have it configured right with the arms of how to pull that ORU out with the loads that we were seeing. But as far as overall arm performance, controllability, everything associated with Dexter worked just fine. So now we're getting ready to go do the HTV checkout task with Dexter. That'll be, I think, around December. I think we're 12/6 and 12/7. We'll get Dexter back up in operation, and we'll be going to the FRAMs that we're going to bring up on this mission to manipulate them around to get more comfortable, get more runtime on Dexter for the mission that comes up when we do this for real on HTV-2. Science continues on board the International Space Station. We're still somewhere around 25, 30 hours a week. We've actually had some major rack moves this week. Within the complex, we've relocated, or today we will relocate the microgravity science glove box out of the Columbus module and put it in the lab. Room was freed up in the lab once we moved all of our regen racks over to Node 3, and we also moved a Melfi rack earlier in the week as well. As far as our upcoming vehicle traffic, we have a 37P undock on Monday. In fact, we had the go, no go is probably going on right now in our IMMT. We have a 40P launch on 10/27 with a docking on 10/30. The Russians have moved their EVA-26, their stage EVA-26, a couple days. That'll now be on 11/15. They were talking about back-to-back, or close within a week, of EVAs 26 and 27 occurring within a week. They have since slipped out EVA-27. They need to get some additional cargo up on 40P to support that EVA, and so we'll go figure out where we're going to go put Russian EVA-27 in the timeline. But they're targeting sometime in the January time period. With that, and the primary task of EVA-26 is to bring inside a couple payloads that they have out there. 23S landing is still scheduled for 11/29. And that gets us to the next Soyuz launch, and I think most know about the transportation issue that they had on transporting it down to Baikonur. They have since changed out the descent module of the Soyuz. They flew one in from Moscow. It arrived. They have already taken the old descent module out. They've integrated the new descent module in. So integrated testing and hookups, everything they do for pre-launch checkouts are going 24/7. They have indicated to us, though, that it will cause a two-day slip in their launch, and so we're probably going from 11/13 to 11/15. And with that, we are staying very, very busy on board the station, and just like to say, on November 2nd, we hit our 10-year human presence on board the International Space Station. So quite a milestone for us. And with that, that's all I got.
Okay, thanks. We'll take questions here and then check the other NASA centers, KSC and headquarters. And Jeremiah, since you're on that side, we'll work that side and then come over here and we'll start in the back there with Mark.
Thanks, Mark Carreau for Aviation Week. And I had two questions. One for John Shannon. You mentioned sort of a floor on personnel around 300 at the end of the program. And I wonder, I think you're talking contractors on the numbers you gave us other than when you designated civil service. But when you get to 300, will they be in charge of preparing the orbiters for museum duty, so to speak, or is there another activity?
Yeah, it's hard to put one number on it, Mark, because it's a sliding kind of scale. There'll be a significant layoff after our last mission, and the vehicle is what we call down mission process, basically safed. Then we'll have the significant layoff. We have identified the personnel that will need to stay around to do things like safing hazardous systems, getting pyrotechnics out. And actually all across, there's shuttle equipment everywhere. And at Marshall Space Flight Center, at Stennis out in California, here at JSC, it will take a small group of people to go through and prepare them to be dispositioned in whatever way they may be. So, and that 300 people is kind of the beginning number, and I would expect in a year it would probably be about half that. And then a year after that, probably half that again. So it's a big job to get through all of the hardware and facility structures that we have. But we've had some time to get the plan together, and I think it's a pretty solid plan.
Thank you. I had a question for Dan Hartman, too. You mentioned the descent module change out. And I hope I didn't read too much into this, but you mentioned that it was flown in. And I just wonder if that's going to be like a permanent change in procedure, since there were some questions about whether it was damaged by rail shipment.
They have not told us if there's a generic change. I would almost be convinced they're doing this because of the urgency of the schedule that they were trying to meet, and they had it there. They could get it there into the airport, into Baikonur, and then they just trucked it over to their facility. I have no indication that this will be a generic change for them. I know obviously they have the commission out looking into the overall transportation efforts on how it goes from Moscow down to Baikonur.
Robert.
Hi, Robert Perlman with CollectSpace.com with two questions. First for John. You talked about the improvements made to Discovery and the continual improvements made to the fleet. But given this is the last flight of Discovery, if you can approximate how much of Discovery is as it was the day it launched 26 years ago versus, I mean, is it mostly would you call it mostly a new vehicle versus mostly an original vehicle? How would you describe the condition of Discovery?
Thinking. The structure obviously is unchanged from when it rolled out of California, out of Palmdale. The TPS obviously, is mostly the same, other than any damage that might have happened and has been repaired. Payload bay is basically the same. In the cockpit, though, of course, we did the cockpit upgrade with the MEDS system, which is our glass cockpit, which was a significant upgrade to the vehicle. But for the most part, it's as it rolled out of Palmdale, and we've just done some safety and usability improvements, but not that different. Probably the same as any 25, 30-year-old airplane, right?
And for Dan, you mentioned the upcoming 10th anniversary of human presence on the space station. Can you give it a report card, how the space station has performed to expectations, fully crewed for 10 years?
Well, I'll be biased. I'll give it an A, right? We've struggled at times. Early systems. We had some early MDM problems. We had some early CMG problems. The Russian side, with the Electron and Vozduk. Once we got up, kind of the redundancy built into the system, it just made it that much more robust, and we feel like we can rely on each other to get us through any kind of downtimes. And we have those kinds of discussions all the time at the IM&T. I mean, it's almost on a daily basis where we talk about, hey, I need to do some maintenance on my system. Make sure you have enough spares on your side to go, pick up the slack. And that's just kind of routine business. So, overall performance, after the Columbia accident, we went down to a crew of 2. That was a very challenging period on the vehicle to maintain it and sustain it. But once we picked up assembly, we had a computer glitch, we had a torn solar array, but then you're into kind of the more nuisance, stuck bolts and latches won't come free, and just got to go out there and deal with it real time. I'm extremely proud of the team. It's just a major, amazing accomplishment to take it from a node and an FGB to the structure that we see today, and then have the presence on there for 10 years. And now finally, I shouldn't say finally, we've been doing it for the last year or so, but really picking up on the research. And so we're committed to the upmass that the research community needs. They basically have a free reign of all the upmass that they can muster up right now. We're always working on efficiencies and ways to improve the crew time for them. And to date, they've come through. They've had to wait for us a little bit, but they're over 600 strong in the number of experiments accomplished on Space Station.
Bill Harwood.
Bill Harwood, CBS. A couple of questions. First for John, if the sealing, the seal R&R does not solve your problem for whatever reason, is there any scenario where you can change out that flange and still make the December window, or would something beyond replacing the seal push you in the next year?
I don't know, Bill. We haven't run it out that far. I fully expect that they'll demate the flange, take a look at the metal surface polish if needed, put the seals in, and it'll work just fine. If there's some other problem or significant flange damage, or if we don't, if we damage it somehow in trying to repair it, then we would lay that schedule out, but we have not done that work yet.
And for Dan, we were talking before this started about Soyuz entry issues with the pressurization system. Could you go over that again? And given the descent module issue for the flight coming up and a few other little issues they've had, I mean, I don't know that any of these are major in and of themselves, but are there any concerns of workmanship or anything else as the Russians accelerate their flight rate to support ISS as it is today?
I mean, that certainly comes to mind, although I think, for the last, typically for the events that are over there, we're involved in, we're on the ground there, so we're listening and hearing, and we're discussing some of the issues that they've had. As far as the O2 system and the leak that they had on the last mission coming home, it actually occurred just a few minutes before the undocking, and the pressure did go up. The PPO2 did go up. It did not violate any of their requirements. As they went through descent before they dropped off the HAB module, they did offload a little bit of pressure to the HAB module, which I think is kind of almost a standard practice for them if they get into this scenario. The crew was trained to do it, and then they had a nominal reentry. I will also tell you that on the last Soyuz that went up, they also had an O2 regulator issue that they are trying to piece these two together and see if there's just some sort of manufacturing, this lot is of any kind of particular concern. And so they're working through that now. They have that commission up and running as well. Early indications to me are they're looking at some seals associated with a valve, but they will report out to us. They report out to us at our readiness reviews. They have their own general design review, much like we have our FRRs over there. That go through all their anomalies, that go through all their open paper. A very, very similar process to what we do, and typically we're in attendance in those. But for the O2, they're troubleshooting it. We actually took, there's a common regulator with the progresses as well, just a couple of days ago, since we have 37Ps getting ready to leave. We've brought all of the excess O2 into, basically into the stack to help us out metabolically. And then they have since taken out that regulator as well. And so they're just trying to get more assets and what's going on. And they will They have told us they're doing a thorough inspection of the regulator in this area for the 25S launch.
Gina?
Asked and answered.
Eric, do you have anything?
Eric Berger with the Houston Chronicle. Thanks for answering the workforce question, John. I can ask something else now. There's still some uncertainty about the summer flight. Obviously, you guys have to be working on that if you're going to go fly in June or July. Sort of, in terms of your own work group, sort of what is your confidence that that mission is actually going to happen now, and talk a little bit about the challenges of preparing for that mission, but still not sort of having the authorization to go and do it?
Yeah, that's a good question. I would first say, what you're talking about is the summer flight, which is right now our rescue vehicle flight, 335. And the discussion is still ongoing, but we have to point out how important that flight is to the International Space Station. And, I think Dan can tell you, in great detail, from a logistics standpoint, I think that 2012 is going to be a real challenge for them. And if there are delays in any of the new vehicles that are expected to deliver cargo to the station, that problem is just going to be exacerbated. And I asked my guys, it's hard to figure out, to compare vehicles and capabilities, but my operations guy said one shuttle flight is roughly equivalent to about 7 progress flights. Does that sound about right? So if you think about that, I mean, that's an amazing, you can get pretty well on one shuttle. And so getting to fly 135 late is going to give the space station margin from a logistics standpoint to keep 6 crew up, to keep doing the research, to keep doing the utilization, even if some of those new vehicles are delayed by some period of time. When the authorization bill was passed, some people questioned our plan to continue with the workforce downsizing as much as we have. And that was a very difficult decision, but the plan we have put in place allows us to carry through enough money to be able to keep the program going and make the decision on whether we fly 135 as late as possible. We really can't make that decision under a continuing resolution. We need an appropriations. And I'm not sure when that is going to show up, but if it shows up even as late as February or March, we can keep the program intact to preserve the option to fly 135 in the summertime. The downside to all that, or the thing to really think about, is the people. I had said before that if we launch our last flight in February, that we're going to have a big layoff in the middle of March. And by law, you have to provide a 60-day notice to those folks that they're going to get laid off. And that would end up being sometime around the middle of January that those notices would go out. What I would like to avoid to stop the stir in the workforce is sending out the layoff notices for March and then turning around 2 months later and saying, hey, just kidding, we're going to actually go until, the summertime. And that's not, in my opinion, very fair for this team. What I think we have done is we have let the team know that that is a possibility. And I've gotten nothing but understanding from the folks. They understand exactly where we are in the authorization appropriation cycle. The team has to prepare Atlantis for flight. We have a good plan to take up logistics even if we flew it as a rescue mission. So there's very little difference between what a 335 rescue flight would look like and a 135 mission would look like. So there's really no difference in our preparation. There's sufficient funding to carry out the decision until very close to February, March, when we would fly 134. We're just trying to optimize it to not perturb the team with layoff notices. So I think the whole team understands the shuttle program is coming to an end. They need to get on with planning their lives, what they're going to do post-shuttle, whether stay in the space community, go to other industries. and we need to allow them the time to do that. And that uncertainty makes that difficult. So the sooner we know, the better. But the process we're in is pretty well understood. I would point out that it's probably a good discussion point to make. We are doing a lot of workforce surveys, a lot of things to kind of gauge the focus and attention of the team, make sure that we're going to fly these very safely. We're also working very hard to have job fairs and workforce transition for the contractor teams to allow them to find new jobs. And I've spent a lot of time with the companies that come to the job fairs, and the common comment from just about everybody I talk to that is a recruiter is that this is not your typical workforce. The engineers that have come into the contractors or to work for NASA directly, they were the best of the best coming out of school, and they have this experience of working in an operational space program. The technicians that have come in work in a safety culture that is unlike any other out there, and they work to incredibly fine tolerances and do amazing work. So I think there has been some more comfort in the workforce that there is a lot of new work out there. In Florida, it's not in Florida. It seems to be outside of the state. In Texas, it seems to be within this area. So the folks that are staying with the program are just kind of savoring the adventure and looking forward after we finish this outfitting of the station and retire the shuttle safely that they'll get on with the next thing, whether they stay in the space community or whether they go and improve the companies in aviation or electronics or IT or oil and gas or wherever they go. And it was related to me, the story of the Avro Arrow, which folks ought to know if you know your space history, that when that program was canceled in Canada in 1959, the probably biggest beneficiary of that cancellation was the Space Task Group at Langley, which eventually came to the Manned Spacecraft Center, which is now the Johnson Spacecraft Center, to execute the Apollo program. And some of the very highest leaders of that program came from the cancellation of that Avro Arrow program up in Canada. And I see the same thing happening here. As we release this incredibly talented shuttle workforce that has this background in operational spacecraft, it's going to benefit commercial spacecraft companies, it's going to benefit aviation companies, it's going to benefit electronics companies. I think across the entire spectrum of industry that folks are going to go out and benefit from it. And this workforce is greatly desired. They are finding jobs, and even in this incredibly difficult economy. So I would just say this is not your typical workforce that we're trying to place.
Anything else, Eric?
I just, maybe to follow up a little bit, what kind of confidence are you working with, at least in your own mind or within your top program people, that the flight is actually going to happen as a logistics mission to the space station? 80, 90% sure it's going to happen?
I don't know.
Okay.
I don't know. I have nothing that's swinging me one way or the other. I told my team it was 50-50. They'd be prepared to fly 335, and that will prepare us to fly 135 if it becomes an option.
Mark.
Hi, Mark Kirkman, Airspace News. A couple questions. First one would be for John. Can you relate how you're going to approach Discovery post-landing? Do you need to keep it in a certain configuration to give you flexibility with dealing with the next two flights, or is there a certain point where it officially becomes unflight worthy as a vehicle again? And then I have a follow-up.
Yeah, that's good, Mark. That's been a debate within the program, is do you keep Discovery in some kind of a flight-ready state to provide spares or provide options? I'm not in favor of that option, although we haven't completely decided it as the program. My opinion is that we need to get on with business, that we need to, once Discovery is at wheel stop, that we can immediately start to reconfigure the vehicle as a display. We are in the middle of a very significant effort to identify hardware off of Discovery and also in the spares that could be used for some future as yet unknown program, or that we would want to maintain as spares for Endeavour and Atlantis. We're also going to pull some off as engineering teaching units so that future generations will be able to take the hardware that was flown on the shuttle and dissect it and understand the engineering and how it was put together. We're also going to go in and look at some hardware on Discovery that has flown for 30 years that we've never looked at before. Things like actuators and some structural areas that are impossible to get to. And those will be fairly invasive. It'll take time and it'll take money, but I think that's one of the legacies the shuttle can provide is for a real reusable spacecraft over a number of flight cycles, what is the real condition of the hardware? So really 4 areas that we'll be looking at with Discovery is hardware that can be used for future programs, hardware that we would want to have as spares for Endeavour and Atlantis till the end of the program, engineering, test or education kind of units, and the last one is hardware we would want to take off and either do destructive testing or some kind of significant NDE to understand its state. So even after Discovery lands, we will not be finished learning about the space environment. We will even learn from the vehicle post all of its missions. That's my goal, is to start immediately on that. It also, because we're in a constrained fiscal environment, it allows me to get that work done and then get that workforce off the books. And that's another, we're having to make tough decisions right now, very difficult decisions as we move forward. And anywhere we can save money and get on with business, that's where we're headed.
Just to follow up on that, you said the debate's still ongoing. Do you have a date when you have to kind of commit to one path or the other, since we're only about a month away, I guess, from wheel stop?
Yeah, it's sure. Go ahead, Mark.
Oh, I'm sorry, I was going to break the next question. Go ahead.
The study is not finished yet as to what hardware we want to pull off, and the total cost is not totally assessed yet. Where I am leaning is to get on with business. And we know immediately post-mission, the down-mission processing will give us some extra time to make that decision. So it's probably about a month after landing we have to have the plan in place. So we still have a little bit of time.
And then the last question for John. You mentioned the boundary layer DTOs. It was such a big deal when you have gap fillers, protrusions, and so forth. I was just wondering, because I have seen no data from so far, have you learned whether you were maybe too conservative, maybe that thermal environment was more benign than you thought, or is it worse? What have you learned from that so far?
Well, and the reason we went and got the gap filler right was there were such big uncertainties in our analysis capability, right? And that stemmed from 2 things. One is you didn't know how this flexible gap filler would bend over or fold, so actually what the height would be. And then we had a very large error band around when we would trip the laminar flow into a turbulent flow and get the increased mixing and heating. So what we did is now we can control the protuberance height exactly, and we have thermocouples in the back that show exactly when you trip and exactly what the temperatures are. And what it has shown is that we trip later than our worst case, and the temperatures are significantly lower than our worst case. So our models have been updated, and I actually haven't asked that. If we went back and looked at the gap filler on was it 114 when Steve Robinson pulled it out, right? If we would have made that same decision given our updated models, I am pretty sure that we would not have done that. But at the time, you don't know that, and you take the best analysis that you can. I think it's great that the team picked to keep the aerodynamic surface on the underside of the vehicle. Tiles are different thicknesses, and so they picked a very robust, high factor of safety tile area, and put these thermocouples in and put the protuberance in, which a lot of people were a little nervous about, right? Because we're trying to protect the underside of the vehicle as much as we possibly can. But people said, hey, we need to understand this for future vehicles. We're also putting a catalytic coating on some tiles that are downstream from that protuberance, and that catalytic coating is what is proposed for the back shell of the Orion. So as you have that very turbulent weight coming off of your heat shield and hitting the back shell of Orion, is the coating that you're going to put on there going to be sufficient? Well, hey, we have a great arc jet in the returning shuttle. We'll put the coating on those tiles downstream from it. You'll get that mixing at Mach 18. You'll get that higher temperature. You can see how that coating does. And you can also see how the difference in that thermocouple under that coating changes from the thermocouple in an uncoated tile next to it. And it's a great experiment, and the team has done a great job pulling it off. And boy, shame on us if we haven't gotten the results out there so that everybody can see them, because it's some pretty impressive work that has been done. Go ahead.
It's Philip Sloss with NASASpaceflight.com. I'm not sure if this is for John or Dan or maybe, but I understand there's a fourth EVA is being added to the ULF-6 STS-134 mission. Can you talk about what's going to be added in that fourth EVA?
Not off the top of my head.
Question for Dan.
Yeah, thank you, John. I'm going to have to get back to you. And it's true. We have recently added the fourth, and I'm just drawing a blank on. That's pretty far out in the future there for me when I'm almost a real-time guy. So we can get that for you. Sorry about that.
Let's go on PRCB today. So,
How is it?
You have good sources.
So you haven't approved it yet?
I have not approved it.
Okay, sorry.
Get Leroy over here.
Anything else? Any other questions over here? Let's come back, Mark. I want to go around to the other NASA centers first, and then we'll catch whatever we can back here. Let's head to the Kennedy Space Center, the launch site, for some questions.
This is Marcia Dunn of the Associated Press with a question for Mr. Hartman. Some of the contractors here are talking about if that 135 flight is approved. The word on the street is that perhaps the space station program would like it as late as possible, perhaps fall of 11, maybe even November. Is any serious thought being given to, if it's approved, pushing that flight out a lot beyond June, July?
Marcia, not that I'm aware of. Probably some of the discussion goes, are there any critical ORUs that we would like to get up on that 135 that we have in the production flow right now? We haven't really gone through and looked at all the details of where those might end up and how much risk we would think if we accelerated a lot of those developments, would we be there on time and give us a little bit of margin? So that would be the only discussion that I know of that would be pushing around June, July. Certainly that's what we have been thinking and talking about within the program. But we are looking at our critical ORUs list, and if that list happens to pile up, if we get this extra flight, I'm sure that might be a discussion point that we have with that Self will have with John and Gerst and the folks.
Thank you. And you have a seventh crew member on board that you haven't mentioned yet, Mr. Hartman. R2, could you just sort of talk about the big picture? I know there are briefings later today on that, but what do you see this robot bringing to the space station program and beyond?
Seventh member here pretty soon, not quite yet. Proof of concept demonstration is what it's going to, is what it's all going to be about. The concept is we're going to be operating it from the ground. We'll start slow, build up some tasks to see how useful and how much IVA crew time we can get some efficiencies out of. But I imagine it'll be a technology demonstration for the first year or so, just to prove the concept out. And like you said, there's many more people behind me that can talk really a lot about that. But it's going to be exciting to have Robonaut up there.
Hi, it's James Dane from Florida today with a few questions for John and one for Dan if there's time. John, first, if the flyout continues on schedule, can you say at this point exactly how much a 135 flight would cost and how would it be funded?
What we asked the Congress for in the appropriations was $600 million extra to extend the program out through the really the July timeframe, and that is still still the figure that we have put out there. We'll see. It's a little bit to Marsh's question as well. If we had the additional $600 million and with the amount of money that we've been able to save through making some of these tough decisions over the last year, I have asked the question, this is probably coming from me, I have asked the question, how late could we fly the 135 mission? And Mr. Seferdini and I talk about it a lot, and it's a very simple premise, right? Is that if you're doing this to add additional logistics to give you some margin for when your next vehicles are going to come up, it would make sense that the later is the better. And so we've had just initial discussions on from a budgetary standpoint, without really looking at the real logistics schedule or when ORUs are available or range or any of the other constraints that we have for actually launching the vehicle. How late could we go just from a budget standpoint? And I can't understate, I can't overstate how much it will benefit the space station to have an additional flight in that time frame. And to me, if we don't fly 135 and the new vehicles that are going to deliver cargo are delayed, and we end up having a logistic shortfall in 2012, and we have to go down to 3 crew, and we're not doing research, we have made a major error, in my opinion.
Thank you. Just given the recent layoffs that you've discussed, I wondered if you could say if this upcoming launch represents one of the most challenging that you'll have overseen, or is that, how much of a factor is that heading into your November 1 launch? Obviously, momentum overall building toward the end of the program as well, and just wondering, is that making this a different experience for you, or is it just like any other launch that you're getting ready for?
I'm ready to launch. We've had this gap while we waited for things to show up to go fly, and the team gets a huge lift from having a launch. And we'll see small issues surface in the program, and we always kind of say a launch fixes everything, because it's such a morale builder and the team works together so well in executing a mission. We've been very, very careful in the workforce reductions that we have made to maintain critical skills. Most of the workforce reductions are in the production side. The operations team is fairly intact. Our sustaining engineering team for all of the elements is intact. We have good, what we call bench strength. I will tell you also that I have been getting a lot of scrutiny from people above me and other organizations that provide oversight to NASA about how are you maintaining safety? How do you know that you have safety in the program? And we're spending a lot of time working on that. We had an independent study done by Brian O'Connor in his Office of Safety and Mission Assurance. And this is nothing that you want to just sit back and accept. You want to keep pushing on it, but I'll read you the results. Was that the government mandatory inspection points, the GMIPs that we do to inspect to make sure that the hardware is received in the proper configuration, that our rejection rates are at historic lows and very stable, that our material review boards, which disposition hardware that is maybe not per print, our rejection rates are still showing a downward trend, so we're not having as much MRB activity. Process nonconformances have been in a downward trend for the last 3 years, and are continuing that. Process escapes that we document, and we bring in quarterly all process escapes in the program, even if it was just to one project, and make sure that we transfer those lessons learned across all the projects. They're at a historic low. Our work authorization documents, technical error rate, basically the instructions that the technicians use to put the vehicles together. we have a 4-year error rate that is continuing to decline, and the overall rate is stable below 1 error per 1,000 pages, which was our goal. And in-flight anomalies, which since return to flight, we classify, I think, everything as an anomaly. We don't have any of these. Well, it didn't work quite right, but we're not going to call it anomaly games. We don't do that. The last 3 missions have been below our 12-mission average. Now, so I look at this report and I think, okay, how do we keep doing this? And the other question I ask is, okay, do we have less people reporting things? And that's why our numbers are going down. And so we've done studies on the human side and to make sure that the reporting process is the same as it has been, and that we're getting equivalent data from previous flights. One of the reasons it's lower is we're not in production anymore. But most of these things are after things are produced and they arrive at Kennedy Space Center for integration. So overall, the program is very healthy, but I have a very high sense of paranoia that this is a very difficult time for the team, and we need to be incredibly vigilant. And any little noises that you hear, you have to go pay attention to and really make sure that you fully understand what is going on, and because it's a very complex process and very unforgiving. And so far the team has been doing an outstanding job, and we're going to continue to stay focused. And the team really wants to preserve the legacy of the shuttle program and end on a really high note.
Thank you very much. And wrapping up for me, John, I wondered if you could just reflect a bit on Discovery's career and what you think it's going to be like to retire this fleet leader, and also for Dan, I just wondered if you could elaborate a little bit on the point John's been making about the logistics challenges ahead. When do things start to get dicey for you if you don't have a commercial resupply mission?
Yeah, so my rearview mirror is kind of turned down until we finish the program. Discovery obviously is a special vehicle, as all of them have been, being the vehicle that put Hubble up, that was the return to flight vehicle twice. You might even say it was the return to flight vehicle 3 times, because we flew it on STS 121 after we went down after 114. It's an outstanding vehicle. We've learned a lot from operating Discovery. We've learned a lot from operating the space shuttles. I am greatly looking forward to using that experience and taking the next step. And I think that across the shuttle team, now that acceptance has kind of taken hold, that hey, the program is going to end. We're going to end it right. We're going to get station configured exactly the way we want it to be. And then we're going to take this expertise and we're going to move on to the next step, and everybody's really looking forward to that adventure.
Let's see, on the when the vehicles are coming in and where we might have a pinch point, it's at the tail end of 11 and 12, as John kind of alluded to earlier. And so when you get into this discussion on 135, 335. We've had discussions internal to our program that we want to load enough consumables on that flight to potentially go for a year. So let's say food and those type of consumables. So obviously we would have a lot of that already on board. And so we've, Mike has kind of challenged the team. It's like, hey, what is it really going to take if we can load that MPLM up with a year's worth of supplies for the crew? And we would probably do that potentially at some expense of some less critical ORUs. So that's that kind of shows us that we're concerned about it. Obviously, a lot of these CRS vehicles are there's demonstration flights that still need to happen, and then CRS needs to pick up and go. They're on the books. We need them, and we are very hopeful that they'll be successful in getting there on time. But there is risk, there is development out there that still has to be put behind them, and it's just prudent for us to take a look at the what ifs and the contingencies, and so that's what we're looking at as well. And then the other part of the 135 flight is, you know, we can get some critical ORUs home, and it's this tear down and understanding some of our failures. You know, we have the pump module that we're preparing, like I said, on these EVAs to bring that home potentially on that flight. So that'd just be a great source of information to try to further understand the root cause of why that pump went down.
Hey, it's Bobby Block from the Orlando Sentinel with a few questions for John. First is, could you tell us a little bit about how the flow is going for 134? There's a few rumors around that there's some payload issues again and there might be a delay. And linked to that, I was wondering about when you were talking about earlier about looking at the idea of possibly when you're talking to Mike Suffredini about pushing things back. I mean, what would be the latest time that you would contemplate a pushing 135 out?
Bobby, hey, on 134, I have no idea.
Yeah.
We've talked about delaying it 1 day to February 27th, but that was not an issue with payloads at all.
Maybe
So
an ATV backup docking capability or something like that. I haven't heard of any payload issues either from AMS, ELCs.
So if you have a more specific, I'd be happy to answer that. As far as how far could we push back June flight, it all depends on money, and we'll see. I don't have my actual costs from October, since this is the first, we're still in October. And I'll have those in December timeframe, and I'll understand better the impacts of the layoffs that we did. And as we go through, if we see what the appropriations numbers are, and we work with headquarters on the money, then that will define how far out we can stretch this program. We are at about, our target was about $125 million a month, and we're under that to about $112 million a month is what it looks like. So, you know, every month that goes by, we're buying back a little bit. Now, you know, we can also use that money for other things, and that will be the discussion on the priorities. Does it make sense to delay a little bit to put ISS in better shape, or do we want to take that money, lay off the workforce, and go step out into the next activities that we're going to do? So it's going to be a lot of discussions between now and the summer if we're going to fly 135, exactly where we go fly it.
And one final follow-up, which is looking very much to the future. I know a lot of your team was involved in looking at possible designs from where do we go after the shuttle program. And I was just wondering, since there's so much talk about a shuttle-derived vehicle following on, do you think that it's possible that you're going to make NASA can make a 2016 deadline for the next vehicle, or do you think that it's far too early to say?
Well, again, it's going to depend. I think that's going to be our direction if the appropriations follows the authorization, and I know NASA will pull out all the stops to get there. And as far as designs on HLLV, the Marshall Space Flight Center has been doing a great job here of coming up with different designs, and schedule and cost are, I think, their biggest concerns, and they'll keep working through that. So, you know, if it's our direction, we're going to work towards that, and I think the team is certainly capable of doing that. But we'll see what the final language says.
Okay, up to NASA headquarters in Washington, D.C. for a couple of questions, please.
Hi, this is Denise Chow at space.com. Just a really quick question for John, and then a question for Dan as well. About the seals on Discovery's seal lines, I just wanted to confirm that the repairs can be done safely and effectively with Discovery on the launch pad, and what the potential risks are involved with that.
We will make sure that we do them safely. The plan on the launch pad is, I think, is a good one. We're going to drain all of the hydrazine out of the tanks. We're going to educt them. We're basically going to pull a vacuum on them and dry them out before they break it. But they will still be in escape suits, the full enclosed suits. In the there's some puts and takes. We talked a lot about, do we want to do this fix horizontal in the OPF, or do we want to do it vertical on the pad? And it was kind of 50-50. The access to some things is better in the vertical, access to other things is better in the horizontal. And the team feels very confident that they can safely accomplish it. The access, I relate everything to working on a car, right? But it's kind of like working on your car. It's 3 inches, on the backside to get to the bolts and separate the system, and then they'll look at the sealing surface and polish. But I think they have a really good plan. The Cape and the techs that work on the vehicles, they're miracle workers, and to me, I always I think they can do everything, and I always side on the fact that, hey, we're going to go put the vehicle in the best possible config, prior to launch. And I need to knock wood here, because some of my peers said, well, what if we mess up the flange more trying to repair it? I don't even consider that. The guys just do an unbelievable professional job. And if we did have something happen on it, then they'll fix that too. So we'll get it in the right configuration before we go launch, and understand exactly what we have, and we'll do it safely. And if it takes more time, it takes more time. And that's the way we've been approaching things here the last couple of years.
Thank you. And just a question for Dan now. You mentioned the 10th anniversary of Expedition 1 arriving at the ISS and the start of the continuous crew habitation. What's the significance of that 10-year milestone, not only for our country's space program, but international cooperation, and what does it mean for the future of the ISS?
Yeah, I think you hit it. The international cooperation aspect is kind of what I hold my hat on. It's just, we had to do it with other countries. It's just been an amazing feat to be able to get there. Exposure to long duration, understanding our regenerative ecosystem is just going to be completely, transportable into any other kind of vehicle we develop for long-term exploration. It'll be critical to that. All the medical research, all the human research that we're doing to understand the effects on the human body, in my mind, just directly applicable. So as we go forward, we're making plans to 2020 with understanding our capability out to the 2028 time period. So we're hoping we can keep this thing going.
Okay, we're back here for a couple of wrap-ups. We'll get Mark and then Bill.
Thanks again, Mark Carreau from the Aviation Week, and it's for Dan Hartman. I think you mentioned on the descent and the last launch, the descent module had a O2 pressure rise. I just wonder if in each instance that was in spec, and why that is a concern that you really need to chase down.
And again, we'll have to get with NERGA to get the more details. Their commission is still ongoing, so just kind of anything I say is kind of what I have heard, and I'll wait for that kind of official. Obviously, if you have an O2 leak, it was past a regulator, and I believe they were manipulating a valve, and so potentially a seal on a valve may have came loose or got misguided and then realigned itself after they manipulated it a couple other times. Total pressure, I think they were starting to get concerned, and that's why they vented it off into the HAB module. Where you can get into trouble is in a PPO2, a partial pressure of oxygen, total oxygen concentration into the cabin. That's where you have some pretty strict flight rules and ground rules, and to my knowledge, on either case were those violated.
Let's see. You have one last one right up here.
I have a question for John that I doubt there's an answer to, but knowing John, he's certainly thought about it, and I'm curious about it. If and I don't even like to mention aborts, but if you had an RTLS on 133 or 134, would you have a chance to fly that flight again with the current budget environment, or would an RTLS end that mission? I'm assuming a TAL would end it for sure, just because of the time it'd take to get an orbiter back, but I was just curious how aborts could be handled from a budget standpoint with these final 3 missions. Thanks.
I don't have an answer. I don't know. Again, we would weigh what caused the abort versus how important it is to supply ISS. And you know, the problem with an abort, right, is I have very limited set of flight hardware, right, and I would expend one, and so that would take the 135 off the table, and then that would change the crew size for 134 because it'd be a Soyuz rescue, and on and on and on. So it depends. It totally depends on what caused the abort, and then you would decide whether it was safe and appropriate to fly the next mission.
Okay, well, that's all the time we have for this briefing, but stay tuned. Coming up at the bottom of the hour is the mission overview. You'll hear all the details from the two lead flight directors, Brian Lunny for the Space Shuttle portion of STS-133, and Royce Renfrew, who is the lead flight director for the station side of the ULF, the Utilization and Logistics Flight 5 part of this mission. So stay tuned for that at the bottom of the hour. Thanks a lot, gentlemen. Thanks, everybody.